Another type of synchronization that we often need in programs is called barrier synchronization. This often occurs when there is a parallel section where several threads are doing something independent of each other. For example, each thread is adding up the numbers in its own part of a shared array. Eventually, we want to know the total sum. So what needs to happen is we need to make sure that everybody has finished their own adding up, and that's what a barrier is. And only then somebody, for example thread 0, can actually form the total sum and, for example, print it out. We don't want it to print the sum before we know that everybody's contributions to the sum are complete. Another thing that can happen is that we are computing the sum in this parallel way, and then all of the threads need to use this sum. So again, all of them need to wait for the sum to be certainly done, and only then can they proceed to actually use the sum. If thread 0 starts using the sum before making sure that other threads are done computing the sum, then what happens is we are using the sum that may not include all of the numbers that are in the array. Same for any other thread. So the barrier pretty much is a global wait that ensures that all threads have entered the barrier before any of them can proceed past the barrier. So the barrier synchronization ensures that all threads that need to arrive to the barrier have arrived before any can leave the barrier. A barrier implementation can have two variables, a counter that counts how many threads have arrived, and a flag that gets set when the counter finally reaches n. So what each thread arriving to the barrier needs to do is increment the counter, check if the counter is equal to the number of threads that need to arrive. If it is equal, set the flag. If it's not equal, that means we are not the last arriving thread. Then we spin, waiting on the flag to finally become set. Of course, things are not as simple.